section, 10.3, is all about probability and odds. A lot of definitions again in this section. You'll definitely want to write these down, and you might want to put some of them in your cheat sheet as well, so have that out in handy. First definition is the word outcome. Outcome means what are your possible results. Second word is event. An event is an outcome or a collection of outcomes. Probability is the likelihood that an event will occur. That probability could be written as a fraction, a decimal, or a percent. So let's talk about event and outcome for a second. An event would be like rolling a dice. An event could be picking a marble out of a bag. An event could be flipping a coin. The outcome is what happens with that. So what happens when you flip a coin? The outcome could be a head or a tail. What happens when you roll a dice? The event would be rolling the dice. The outcome would be you could get the number 2 to show up. You could get a 6 to show up. Theoretical probability. Theoretical probability means you just think about what could happen. You don't actually have to carry out an experiment or a trial. Theoretical probability is just basically called probability. The notation that we use for that is P parentheses A, so P of A, probability that A could happen. And the fraction that we use to calculate that is the number of outcomes, number of positive outcomes in A, and the total number that you're going to pick from. The shortcut words I like to use for that is yes over total. So if I'm going to flip a coin 15 times, 15 would be my total. What would be the probability that I'm going to get 6 heads? So it would be 6 over total. So what is your yes number over your total? That's how we're going to calculate probability. In a deck of cards, first of all, everybody needs to know in your deck of cards you've got 52 total. Your cards, diamonds, hearts, there are 13 each. We also have clubs and spades. There's also 13 each. Hearts and diamonds are red, clubs and spades are black. The numbers go from 2 up through 10. And then we have the jack, the queen, and the king of each of them. Jack, queen, king, and then we also have the ace for each of them as well. This first question, what is the probability of picking an 8? There are 4 8s in your deck, 1 from each of these suits. So the probability, the yes number, there are 4 8s, and my total is 52. Please try to always remember to reduce your fractions. 4 over 52, 1/13. What is the probability of picking a red king? There's a king in both the diamonds and the hearts that are red. That means there's 2 red kings out of my 52. Probability is 1 over 26. Odds in favor is the next thing that they talk about. You'll want to write this one down in your notes and your cheat sheet as well. Odds in favor means you need to know the yes values over the no values. We have a different number on the bottom now. It's yes over no. Odds against will be the flip side of that. Odds against means we start with the number no. What number is not in the answer that we're looking for, and then divided by the yes values. These two numbers, the yes and the no numbers, should add together to give you the total. That's one clue to know if you're on the right track or not. The yes divided by no, these two values should add up to give you the total in your entire event. And then just remember from before, the probability fraction is yes over total. That's the only one that uses the full total number on the bottom. What are the odds in favor of drawing a 10 from a deck? In favor of, yes over no. How many 10s do we have in our deck? How many are not a 10? Be careful here. Don't just put 52 on the bottom like we're used to. If we have 4 10s, then we have 48 that are not the 10. Do those two numbers, 4 plus 48, add up to give you your 52? You know you're on the right track. and then you can reduce 1/12. What are the odds against drawing a club from the deck? Odds against would be no over yes. Odds against drawing a club, so not a club. The numbers that are a club would be 13. The leftovers are not the club. That's 39 of your total 52. These two numbers do add up to give you the 52, so we know we're on the right track. And then this reduces 3 to 1. What are the odds in favor of rolling a 6 on a standard dice? Odds in favor, we're back to yes over no. If we do want to show up with the 6, there's only one chance that that could happen, and then the numbers that are not the 6 on a standard die would be the other 5. So that one is 1 over 5. And then this last one here, what are the odds against rolling an even number on a standard die? Odds against, no over yes. Odds against rolling an even number on a standard die. Well, you know your standard dice numbers again. Go from 1 through 6. If I want the even values, 2, 4, 6, there's 3 of those. Odds against rolling the even, so which ones are not even? 1, 3, 5, that's 3. And which ones are even? 2, 4, 6. So it's 3 to 3. 1 over 1. Odds against. Experimental probability means that you actually have to do something to calculate your probability. You're either going to do a poll, you're going to do a survey of some kind, you're going to do an experiment, like flipping a coin yourself 15 times or whatever. The probability in that instance is still yes over total, but we actually have something that we're actually doing. So we're going to count our values. You might have to look at a chart of values. If you look in your book, some of the questions, they might have done the experiment for you, and the chart of answers is listed, and you will calculate the probability based on looking at the chart. The geometric probability is a ratio of the lengths, areas, or volumes of objects. So in this particular type of probability, you're going to have a picture inside a picture, a circle inside a square, a triangle inside a square, something like a bullseye. And what you need to do there, you're still thinking yes over total. So what you would be looking at is the object on the inside that is shaded would be considered the yes area, and then the outside shape would be considered the total area. Okay, so you could have a square with a circle on the inside, and the circle might be shaded. What would be the chance that you throw a dart and you're going to get it on the inside of that shaded circle? So you would be doing the shaded circle area, in which case you need to remember your circle, pi r squared, and then the outside would be the square length times width, and you would calculate that way, and they'll give you the dimensions that you're looking for. Here is a really goofy example that I found someplace. I know it's kind of gross, but it's okay. Don't worry, it's not real. If the roach is stuck in a box 10 by 15 inches in size, what is the probability it will stop in the red region? So if I could smush that bug, like right now, except it won't smush, what's the chance it will get inside the shaded region? So think yes over total. My yes region is the triangle. My total is the outside box. I need to know the area of each of these. So if you look at your dimensions, the area of the triangle, 1/2 base times height, yuck, 1/2 times 6 times 5, over the outside square, which is 15 by 10. 1/2 times 6 is 3, 3 times 5 is 15, and then 15 times 10, 150, and that will reduce 15th. 10. Can't do my own math today. 1/10 would be the probability for that. Okay, so just remember that it's the shaded inside region over the entire outside shape. And I do believe that's it for this particular section. Okay, So there you go with probability, lots of vocab again, outcome, event, theoretical probability, odds in favor, odds against, experimental probability, and geometric probability in this particular section.